All right, so if we look at this one, remember that we want to make it look like y equals a sine of b of x plus or minus cb. It's written in y equals a sine of bx plus c. And so the easy thing to do is identify what b is. All right, so b is this negative 2. So everything stays the same, except I'm going to pull the negative 2 out here, but I also put the 2 here, but because it's negative, this becomes negative. When I crank through the math, I get a equals negative 4, which means I'm going to have an amplitude of negative 4. My b term is negative 2. Because, oh wait, let me back up here. Because a is negative, I'm going to flip it. And then my c over b is a phase shift of pi over 2, but because this is negative, it's going to go to the right, pi over 2. But here's the interesting thing. My period is 2 pi over b. B is a negative 2. So when I plug that in, I get a negative period. So this is funny. This will take it and flip it vertically. A negative period will take it and flip it horizontally. Now for sinusoidinous or circular functions, the flips like undo each other. So one is going to take it and flip it like this, right? So it's like this and it flips. But then the other one will take it and flip it like this, which kind of undoes the flip. So let's look at this, and then we'll graph it on Desmos. So I know that the amplitude will be from 4 to negative 4. And remember, if you make a mistake, you just plug it into Desmos. Even Mr. Adams makes mistakes. All right, so now normally sine would start here and have a period of 2 pi. But because a is negative, instead of going this way, I would flip it this way. But because my period is negative, and it would go from this to flipping the other way, which would be this to this, which would be back to the original. Does that make sense? You guys kind of see that? Okay, so let's figure out where we're going to have the peaks and valleys at. So originally, my period would be pi or negative pi. Not originally, but after this part of the transformation. But because c over b is negative pi over 2, that means I'm going to shift over pi over 2. All right, so let's think this through. Transformation, and I'll transform it in Desmos each letter at a time. So sine normally goes like this, right? A is going to flip it, which would make it go like this. But c over b is, or I'm sorry, the period is negative. So now I'm going to, instead of going like this, I'm going to flip it horizontally, so it'll go like this. Okay? But also, I've got to shift it over to the right. So, how does that look? Well, so I would go like this, but I'm going to shift it this way, so I would go like this. So I'm going to have to come down here and come down and around. Oh, you know what? I did it wrong anyways. Hold on. Don't write that down that way. It's got to go like this. So now it's got to go... This is hard, isn't it? So because I flip it, it's going to go this way. But when I flip it, it's going to go this way, which means over here it should go like this, right? And that will cause, how did I screw that one up? But wait, we got to shift it too. That's the part that's really throwing me off here. Let me think about this again. I'm going to sketch a couple things. Don't write anything down until I make sure. This is a difficult one. So normally it would go like this. We flipped A, it would go like this. So it would go like this. So I need to come over here and go like this, which means we would go like this. Yeah, that's the hard part, is it comes back. I'm going to just guess. I feel like we're going to do this. Is that right? No. Okay.
Would you start on pi over 2 because it's shifted?
We would start here because it shifted, right? And so because it flips, it goes this way. But it flips again the other way, so we would go this way. Right? It's hard. But isn't that what I had drawn? Oh, I know what I did wrong. Yeah, I was going to have it right. It's just kind of hard to visualize. I think the last time I started here and was going to go down like this, and for some reason I stopped because I wanted to get it right. So I think this is right. And remember, this is from 4 to -4. All right, so I'm going to label some points. Hopefully we're right. This point down here should be pi over 4, 0. This point over here should be 3 pi over 4, 0. And it should cross the x-axis every half pi. All right. So let's try to do this in real time. So let me close all this out, because this is what I want you to see. This is the hard part. So if I say sine of x, and I know it's taken the whole class. So and I'm going to put this in terms of pi over 4. Okay. So then the first thing I'm going to do is when I take and I put the -4 here, -4, it flips it. Then over here, I'm going to say -2, it flips it the other way. And then when I say plus pi, it flips it that way. And so, yep, those are right. I think the hard part there is keeping track of everything. That basically transforms everything except for k. So this is every half pi. Whoops. I wish it would just stay on there. And by the way, I'll be first to admit that, like, even though it was hard for me to track all this abstract stuff, but before I would submit this to my homework, because I graphed it, and what did we learn in this process? Even though I made a mistake